And the folks online are hearing me okay? Now I can't see because the lights are all off on my nose. So if you see me peering down at this thing like this, okay. Welcome. I'm excited to talk today about a project we have been working on. Some serverless data pipelines, and you'll understand a little bit more as I get into it why we talked about automated. But let's dig in. So between 1998 and 2003, consider this fact that Google, in that time period of 5 years, created 5 million terabytes of data. By 2010, they were creating that same amount of data every 2 days. And by 2021, every 40 minutes. And that's one company and a stat from 3 years ago. And now the all-consuming data beast, that is AI, is on hyperdrive. Anybody, by the way, see the new released videos on OpenAI 4.0 and not 4.0, but I think it's a -O or 4 little case O, which stands for Omni. It's pretty incredible. If you haven't seen that, check it out. Again, just released yesterday. More data needed. So hands, how many of you deal with data in some way, shape, or form? I mean, the reality is we all do. It is the lifeblood of what we do. Never mind the files and databases that we fill up, the code we write, the images we design. And with the invention of cloud computing, even the infrastructure that we requisition, all of this is data. Moving this data around takes many different forms. Today, we're going to focus on data pipelines, which are simply processes that move data from various locations and in various formats to another location, such as a data warehouse. So let's quickly take a look at what I hope are the takeaways that you get from today. Next slide, we'll give you a chance to update. Let Andrew sneak in there. So first one, as I want you to learn one way to set up a serverless data pipeline platform. Now, I call it a platform because this is not just about setting up one pipeline, but rather building a whole system designed around onboarding and offboarding data sources rapidly. So for those of you not familiar with the term serverless, how I am defining serverless for today's presentation is utilizing services provided by cloud providers to build the entire solution so that I don't have, as the developer, don't have to requisition any servers. And when I say any servers, I'm including cloud-based servers such as Azure VMs or AWS EC2 instances. So even those are off the books. So the next thing, I hope you're going to learn about some cloud services. We're going to dig into AWS. I'm going to reference the comparable-ish Azure services. But the reality is these services are what I refer to as building block services, and you can use them in any application for a variety of purposes. So hopefully that's a takeaway for you. The next thing, that infrastructure as code can really be the entire solution platform as code. Now, if you're not familiar with the term infrastructure as code, this basically means being able to define all the infrastructure and services for your cloud-based application that's in a format that is understandable and executable by a deployment platform like Azure DevOps, and there are many others. So we want to take that all the way to the next level, that the entire solution, not just the infrastructure, is all part of your deployment process. And you'll see why that's more interesting in the case of serverless data pipelines. Finally, we are going to dig into AWS DevOps, but in general, I think there's some more advanced ideas we're doing around DevOps here, and so hopefully you get some takeaways from that also. So are we ready to see the solution? Ready to go and see what we put together, or I would say a solution, because there's never just one way to do anything. All right, well, here's our data lake. Look at the wonderful data lake we have set up. It is so awesome and ready to accept all the data that we are going to bring in, there will surely be no problems, right? So did you like my attempt at Kraken jokes? Hey, it sounds like I'm not the only dad in the room. So let's quickly look at the technical environment. Already mentioned AWS, so we get that. So the data warehouse that we're using is Snowflake, but really for today, we're just mainly talking about landing into a data lake. So it kind of doesn't really matter what your data warehouse is. And the data lake, just to define that term, is wherever you want to land your raw data. That could be SQL tables, it could be some kind of file storage, it could be a combination of those things. It's really just a loose term for where am I going to drop all this raw data I'm getting. The last thing is GitHub. That's going to be our code repository, and it's also going to handle our CI/CD and get our deployments kicked off. So what is it that we're trying to do? So here is our goal. We are going to either make calls to APIs and pull in JSON data, or we're going to receive JSON data from external data sources that are pushing data to us. We're going to store that JSON data into a table in Snowflake, along with some metadata wrapped around it. That's it. That's the entire goal, okay? Doesn't seem too complicated, or is it? We also are just starting with JSON because you have to start somewhere when you're building a platform, and this is the most immediate business need. So our project goals are that we want a very quick turnaround on new endpoints. So for each new API/endpoint, I don't want to be writing code or having to manually set stuff up in the AWS console. That takes too long. It's important to get all the data all the time, especially with the Data Vault style of warehouse. So we have to expect and handle outages and failures. To help with this goal, we need to minimize maintenance effort. Temporary interruptions should be automatically handled. We need to alert when things are too broken. We need to make it easy to troubleshoot, resolve, and recover from problems. We need to easily tear down endpoints that are no longer in use. And we need to make it easy to update and fix and apply fixes with a minimal blast radius to the whole environment. So one of the logical questions that we should all be asking is, there are products out there that handle data pipelines. Why aren't you just buying one of those? Why build? Well, the answer to this question is simply this: one size does not fit all. This is fundamentally why we exist as a company. We're a custom software development company. People need customized solutions. When business needs are considered as well as the cost and features of the various solutions that are available, you might decide that it makes more sense to build instead of buy. In that very same vein, what we discussed today likely doesn't exactly fit your organization's needs. But hopefully you will get some ideas that you can take back to your own teams. And of course, one sales pitch for today: we're always happy to work with your organization and bring our own experiences to bear. All right, so what are some of the challenges with dealing with APIs? There's a lot, actually, as it turns out. Oh yes, and I did rearrange my slide correctly to make sure the little square in the corner doesn't overlap the thing. Fantastic. I was up late last night going, the evil square in the corner. It was more challenging than you would think, especially on some of the diagrams I have coming up. Anyhow, let's keep going on. So I'm not going to read through all of these because there's a lot, and there's even more that I didn't put on the screen, but I want to have a few callouts as to some of the challenges when dealing with APIs. One is they have different authentication methods. So we're going to look at our sample API called the Machines API, and it would seem simple. I'm going to get back a list of machines. But when you think of authentication methods, and you think of people have different kinds of authentication methods, and again, I want to deploy this all automatically based on configuration, the challenges get interesting. With respect to authentication, sometimes you have to actually make a call to get a token first, and then use that token to actually call the endpoint you want to actually pull the data from. So there's some interesting challenges in building a system that will produce these data pipelines automatically for you. Different pagination schemes. Thank you, developers, for always coming up with your own ideas. Appreciate that a lot. So that's definitely a challenge. Endpoints that require an ID where those IDs are sourced from other calls. So this is pretty standard. You say, hey, I have this service history endpoint, but it needs the machine ID. Where am I getting that ID from? Well, I need to call the machines API to get the list of machines to get you see where it's going. So that's another interesting challenge that we had to deal with. And we're going to focus on that last one a little bit more later in our presentation. So what are we going to build? So I'm going to get more into the details of what we're going to build here, but I first want to kind of get us all on the same page on the terms I'm going to be using and the different services and what they do. I don't like going to presentations where they assume you know everything about every acronym I'm going to say and every service I'm going to mention. So I'm going to try to give you a little vocab here. I'm also going to do I've listed the what do I call it? Comparable-ish service in Azure, so that you can see you can build the same platform in Azure 100%. It won't be exactly the same. Things are handled somewhat differently, but pretty much it could be pretty similar. So our first service we're using today is AWS EventBridge. It is a message scheduling service. It can do quite a few things, but that's how we're using it, okay? So it's going to, at a certain time, kick off a message for it, and we'll create a variety of schedules based on that. Something's pumping up on my phone. I got to hide my phone so I don't get distracted. API gateway. So this is for that case where we need to receive data being pushed into us. We need to expose an endpoint that an external source can send data to us. So we will use API gateway. SQS. This is simple queue service. I should have looked up that acronym again, but it is effectively message queue. So for those of you who are familiar with queues, great. And for those of you who are not, Google it. So we're going to use SQS as our message queues. Lambdas. So this is a service that provides the ability to execute custom functions in the cloud environment that you can develop in a variety of supported languages. And DynamoDB, which is it's a NoSQL database, and we're going to be using it to track the state of our pipelines. And parameter store, which is going to be a place where we're going to store configuration and secrets data. And the nice thing about parameter store is that putting the configuration data there gives us the capability to adjust configuration without doing another deployment. All right. Last but not least, CloudWatch, which is our logging and monitoring service. And in our solution, we also tied in to OpsGenie, which is a third party. It's not part of the AWS environment, but it's a third party notification service. And in this case, it includes paging. So we have the ability to say, hey, it really went boom, better page somebody. All right, last consideration here, before we really start peeking under the covers, how do you avoid what you're building in the cloud becoming a stinking hot mess and your cloud bill suddenly going out of control? This is a problem that a lot of teams have faced. They build something and then their costs skyrocket. They're unfamiliar with how to architect cloud solutions, so they're not sure how to approach it. Both AWS and Azure provide, and I wanted everybody to have this just for reference, something called the well-architected framework. Because in our industry, we are really just creative. They are called the identical thing. It's called the Azure well-architected framework and the AWS well-architected frameworks. There are a variety of, so easy to look up, there are a variety of resources to help guide you along the path of building a well-architected solution. So take note of these if you're not familiar with them and you're planning to build cloud applications. They're a great resource. They're not actually going to tell you if you've built one or not. They're just helping you ask the questions about what you're doing and giving you all kinds of resources around that to say, okay, yes, we believe we are on the right path. All right, let's get in. So here's our machines API that I mentioned before. And so let's see what we're going to dig into a diagram here and let's see what we get. We're going to skip the deployment part for this, and we're going to push that to the back end. And Bob Jones, one of the team members, and definitely the primary team member on the deployment side of things, is going to talk more about the DevOps side. But we're going to see what we get once we do put our configuration and hit that deploy button for our endpoint. Okay, so as part of our deployment, we get an event bridge schedule. And this has been created, and this event bridge schedule is going to create and execute an event bridge rule. So that event bridge rule, time for water, will insert a message into an SQS queue. We call this the read queue because it's going to be responsible for doing the read to our API. These queues are specific to each endpoint. So each endpoint, and Bob will talk about that a little bit more, is going to get its own set of infrastructure here. We also get a dead letter queue. So a dead letter queue is just another SQS queue that is linked to this queue and denoted as the dead letter queue. The cool thing about it is that if you drop messages into a dead letter queue because you hit the max retries and things couldn't work, you can go into the AWS console and redrive those messages back into your queue, assuming you've fixed the problem and you know that the messages will now be able to process again. All right, so next, the read queue is associated to a Lambda function. So that Lambda function will, when it sees a message appear in the queue, it'll grab it and it'll start saying, okay, I'm going to process this message. It will then take a look at, and that message is to say, hey, it's time to read the data from the API. That's what it's telling you. So it's going to look at DynamoDB and said, hey, have we read from this API before? When was the last time we successfully got data? If you're in the middle of a process where you're in the, like, did you successfully read page 2 and now we're trying to read page 3? If there's an interruption. So it's looking at all that kind of state information. It's also going to go into parameter store and say, okay, hey, tell me about this endpoint. What's its authentication scheme? What are the actual authentic secrets that I need to get? And other configuration data. So then it's going to, and if it needs to, it's going to make that HTTP request to get that security token, all those kind of things. So with all that, it's going to build our HTTP request that we're going to send to our API. And hopefully receive a response back in the form of a big chunk of JSON data. So now, as opposed to taking that big chunk of JSON data and writing it to a file or some kind of blob store, we decided that we would push all the response data into the body of the SQS messages that will then go into this write queue. The problem is that SQS limits message size to 256K. So we're going to have, as part of our processing, chunking that data into smaller blocks and then sending multiple messages into the write queue so that each block, and you can see it's a FIFO queue. They're all FIFO queues. We configured them to be such so that if I have 10 megs of data and I'm sending it in 200K blocks because I don't want to completely, run on the edge, it will process them all in order. All right. Then after we have our messages in our write queue, there's a Lambda associated with that queue, and it will take on the responsibility of wrapping some metadata around the JSON and sticking it into a Snowflake data lake table. And last but not least, of course, we have CloudWatch, as I mentioned, and it's watching over everything, logging things where we have asked it to, monitoring the processes, and alerting us, as well as reaching out to Ops Genie and sending out the appropriate alerts when things go boom. So that's a high level of our happy path. We're going to dig a little bit now onto what happens when things break and understand the retry process a bit. So let's focus on this area of the screen as we move to the next slide. Okay. So I've added an extra arrow there, as you see. So with SQS, messages actually stay in the queue until they are explicitly deleted. Each time a message starts to be processed, there's a property called the visibility timeout. And that effectively stops the message from being processed repeatedly for the period of the timeout. This gives our Lambda function a chance to process it and delete that message. So if something fails and it can't reach out and delete the message is still there, and eventually it'll show up after that timeout period, and it'll kick off our Lambda again and try to process it. At a certain point, though, we'll hit the max amount of retries configured for that queue, and then it'll drop it into the dead letter queue. We've actually, by the way, this first iteration of all this is running in production, and we have seen it, the endpoints at times like, oh, here's a 504. It's like, oh, what's going on? And then it just retries later. And we also have a backoff algorithm that we've set up for it. And it eventually is like, oh, I guess you were just unhappy for a bit, and then it will just retry and keep going. So that's pretty neat. All right. So let's talk about that other scenario I mentioned, the incoming data, the push or the post of data from a third party. Let's start again looking at the exact same diagram I just showed you for our machines API. But since we don't need to schedule a read of the API, it's being pushed to us. We now don't need this, neither the event bridge schedule nor the read queue. And of course, we don't need a call to the API, but we are still going to use a Lambda function, albeit a lighter weight version of our original. This Lambda function will handle the inbound post of the data coming through the API gateway. But at that point, the rest of the process is basically identical. We can reuse everything that we've got on the right-hand side of our screen. So now I talked about this other scenario. How do I handle the case where, so great, you figured out how to dynamically push out and handle an endpoint, but how do you handle it when like the other endpoint needs data from your endpoint? So let's look a bit at that. Again, let's start where we were from our original machines endpoint API pipeline. But let's not focus on the right side mechanics. Let's just focus on the read side mechanics. And also let's think about, we also deployed a pipeline for that service history API in the very same manner. And we're going to look at the read side of that pipeline. But you see that there's something missing here on the read side. There's no event bridge schedule. We didn't configure one, so it didn't create one. Now, this gets a bit complicated, and hopefully I've explained this well. So we'll see how we go. So we set up the platform so that for any endpoint, you can tell through configuration that it has other endpoints that need data from you. You can also instruct it on where to find that data in the JSON that it will receive. And with some help from parameter store, we can point it to the read queues of those other endpoints or we call the child endpoints. This allows the Lambda process of our machines API to insert a message for each machine ID into the read queues of the service history API. We following? There you go. All that for one green arrow. So here is a who is paying attention question. What business assumption are we making in this specific setup that won't necessarily always be true? Let's think about that for a second. I'm going to work through my one hint. So in our scenario, we have the machines API that's being called on a schedule, hint, and then it in turn sends messages into the service history endpoint which then processes those messages. Any volunteers? The assumption that we're making is we assume then that the periodicity, or how often I want to get the machine data, is the same as how often I want to get the service history data. That is actually not true. So one way you could handle it is, it's not always true, I should say, is I could increase the schedule of whichever one is more frequent. So if I need to get service history more often than I need to get the list of machines, I can increase the machine schedules periodicity to a higher frequency, but then I'm unnecessarily calling that to refresh the data more often than I would need. So the answer to is that's in a future enhancement we're working on. But something to keep in mind. I just wanted to call that out. There's lots of interesting challenge when just dealing with APIs. It's when you do when you look at packages where you can buy the integrations, platforms, they have a lot of pre-built connectors for so many different endpoints, for common ones and stuff like that. And it's because of a lot of these kind of challenges that they do that. It's hard to build one platform that everyone's going to be able to configure and handle every specific case. But it's certainly been fun and absolutely interesting. All right, so a quick overview of the tools we are using for building, deploying the pipelines, and then Bob Jones is going to come and give us more detail on the technologies that we've used here and dig into that. As mentioned before, we're using GitHub for our code repositories, and GitHub Actions is going to be our CI/CD technology. We're using OIDC authentication between the GitHub Actions and AWS. We're using GitHub Secrets as well. And then we're using something called the AWS Cloud Development Kit. This is a CLI tool, and basically it's our infrastructure as code. If you're familiar with infrastructure as code, again, Terraform is pretty common. There are other ways and technologies there, but we chose, even within AWS, there's another one called SAM, and Bob might mention that. But for us, the Cloud Development Kit, the CDK tool, turned out to be the most flexible and powerful for our needs. We're also using Python as our development language. You can do you on which one you like, as long as it's supported in your cloud platform. And then we also use a tool called Cookie Cutter. Bob will talk about that also a bit more, but it's project templating, a tool that he will give you some details on. So I've said Bob's at least 3 times, so I think the genie's out of the bottle. Come on up, Bob, and I'll let you take over and give us a bit more detail into these DevOps processes.
Hi, and thank you, Chris. If we can go to the next slide. So in architecting where the source code and configuration lives, we created several GitHub repos. So the first one I want to talk about is our Cookie Cutter template. Cookie Cutter is a Python-based library and command line tool for generating boilerplate for projects. In this case, what we're doing is we're building CDK app projects. And we also use Cookie Cutter to parameterize the configuration for these CDK app projects. The way it works is you get prompted, if you run Cookie Cutter from the command line, you pass it the URL pointing to your Cookie Cutter template, and it's going to prompt you with information for things like, in our case, well, what's the name of our source provider? What is the base URL for the endpoint? What's the path for the endpoint, et cetera, et cetera. And so with that, we were able to build out a bunch of endpoint aligned repos. And we did this because we wanted to have some blast radius protection. If you make a change to one of those CDK app projects, you want to isolate the damage of the change to only one endpoint. We'll talk about that. Another strategy we could have used is we could have had, and I'll talk about what a stack is later, but we could have associated multiple CDK app endpoints. Actually, stacks per CDK app. I'll talk about that in a future slide. The other two repos to mention are that we have a build time library and a runtime library. We did this because we knew that we would have repeatable code across each endpoint aligned repo. The build time library focuses on CDK abstractions called constructs and stacks, which I'll be talking about soon. And then the runtime library would be anything that's not CDK related. All of these Python-based utilities that will serve the Lambda functions so that you don't have these code-heavy Lambda functions. Next slide, please. So this is a top-level diagram of what's the relationship between these abstractions. The topmost one is your CDK app itself. And within CDK app, you can have multiple CDK stacks. And within each stack, you can have what's called a CDK construct. The difference between a construct and a stack is the construct is your basic building block for putting together related AWS resources, whereas the stack is a deployable unit of infrastructure. You bundle those stacks together, you have yourself an app. Let's move on to the next slide. Now, I probably should have backed up a little bit. I like to think about this in terms of a Lego metaphor. Think of each Lego brick as being your cloud provider's resource. And that resource could be a table, a queue, a scheduling rule. Now let's go one step further with this Lego analogy. Since it was Cinco de Mayo recently, let's say that we're working on building a Star Wars Lego. Let's say it's an AT-AT. Well, we're going to be building a bunch of AT-ATs out of Legos. Some of the pieces of that AT-AT are, they're coherent. Like the legs are going to look the same. The feet are going to look the same. The head's going to look the same. This is where the concept of a construct comes into play, because you're putting together these bricks, in this case, AWS resources, and they're going to be the same in terms of their relationship with each other. Maybe the configuration will differ. Just like with a Lego brick, it could vary by size, color, etc. So constructs are very powerful, and you'll even see online that there are examples of these CDK construct libraries that you can use. In our case, we built our own. Now, nice thing about constructs is they are pretty flexible beyond just working with AWS. You have, for example, CDK for Terraform and CDK for Kubernetes and even Progen. So once you've built these constructs, the reason why you want to amass like a construct library is that you can use these with these other frameworks. Let's move on to the next slide. Once you've defined a set of CDK constructs, you can now begin defining your stacks. Going back to our Star Wars Lego analogy, this would be the AT-AT. The AT-AT would represent a stack because we're putting together all of those constructs, the head, the feet, the legs, etc., to form a coherent, deployable object. This is our infrastructure. On to the next slide. There are instances where you will want to associate multiple stacks with an app. In our case, like I said, we have a repo per endpoint. However, you can imagine a service provider is going to have multiple endpoints, and maybe some of the code is going to be common. and so maybe the resource needs would be common as well. Maybe it makes sense to have multiple stacks associated with that one CDK app. So going back to the Star Wars Lego analogy, this would be the Battle of Hoth, where you have multiple AT-ATs. Maybe let's throw in some ATSD walkers as well. Throw also some snow speeders. That would constitute the app in its entirety. When you go to, and here's the thing, when you go to build the CDK app, what's really doing is it's synthesizing an AWS CloudFormation template. The template is very verbose. You can create a custom CloudFormation template from scratch, but it's a lot of coding. The point of having CDK is it reduces that coding to a language that's more familiar to you. Could be Python, it could be TypeScript, it could be Go, it could be Java. You get to choose. And in the end, what you get is this thing called a construct tree that maps to a hierarchy of CDK constructs. Next slide. I think the next slide is for you, Chris.
All right. No, it's for you, Bob.
Me. Okay, so Chris mentioned that CDK is a command line tool, and you use it to build out your CloudFormation template. You go through a couple different stages. The first stage I want to talk about, even though you see a bunch of blocks here prior to it, is what's called CDK synthesize. And this is a way to locally test that everything that you've written in, let's say, a Python implementation of CDK, you want to make sure that there are no coding errors. You certainly don't want to discover them when you attempt to actually do the deployment up to AWS. So you would do a CDK synthesize. Next up would be CDK boilerplate. So another intermediate step, finally leading to the command CDK deploy. And it's that command that allows you to deploy your synthesized CloudFormation template up to AWS so that it knows which AWS resources to provision. Correlated to CDK deploy is another command called CDK destroy, because sometimes something goes boom and you need to start over from scratch. And now let's move on to the next slide.
All right, Bob, thank you very much. That covers what we have put together today so far for this project, but I'm going to give you a little sneak peek of what is currently in process. Another one of our team members, Oliver, sent me some screenshots here. So this is what we're calling our phase 2, and it's managing the process. Again, same idea from the deployments and stuff that Bob talked about, but it's managing the process that's going to take the data from the data lake tables and then eventually move it in through one staging process into a raw data vault with appropriate business keys calculated and duplicates removed. So to do this process, we're using AWS step functions, which is basically a state machine. So our state machine is going to look at the JSON instructions that are fed to it. It's going to then convert those instructions into SQL statements, which it will hand over to Snowflake, and Snowflake will do the actual processing and movement of the data through the data lake to the staging tables to the raw data vault. So what we're seeing here is a diagram generated by AWS, actually representing the main state machine, which is fantastic because then I didn't have to lay one out like I did all the other slides. Plus you're seeing one of the sub-modules, since you can actually have state machines called state machines. Maybe we'll talk about this in a future lunch and learn sometime, but for today, that's all we have for you. Thank you for coming.